Hello and welcome everybody to my talk about events and some mistakes that can happen with that. Some of you already noticed that I use also a different title for it. Yes, because this is the event failures talk and you can refer to it in any way you want, and I won't mind, feel free. So events uneventfully, or events mistakes were made, or events how to avoid mistakes with events one event at a time or one mistake at a time. Everything is great. My name is Andrzej Grzesik, but I know that for some people it's quite hard to say and spell, so I usually go by Axe, which should be, first of all, much easier to spell over a phone, especially if you try to deal with people who don't usually use sounds like sh or zh or sh and anything like that. And sadly, well, some very bad things still continue in the world, and I like to call them out. Anyway, my name, Twitter, I keep calling it Twitter. I probably will for next couple of years. I also have an email. If you want to have the slides, drop me an email. I'll be very happy to share them. And sometimes I do this talk with a very kind and humble person called Wojtek Prague, but Wojtek couldn't make it to Prague. So if you find a video of me doing it with him, that's absolutely normal. That happens. Normally I would, but he couldn't. So today you get just me. And I also build distributed stuff, and recently I started working at a company called Elmax. You might have heard about it, where I use Linux on a daily basis, and we pair, and it's actually quite nice. A couple other things. I'm a Java champion, have been a Java 1 rockstar. I'm involved in this conference, as you know, involved in Java user groups, speak at conferences, and so on and so on. All opinions are my own, which means I do not represent any organizations. That's important, or a very important disclaimer, don't sue me. And if you have any questions about the talk, you can wave your hand. I will not promise that I will see it, because there is a very bright light shining into my eyes, and this might get difficult, but there is also Slido, which should be much easier to handle. And I like dry jokes. Sorry. So, what is this talk? This talk is basically a collection of problems witnessed, not a complete collection. There are more problems and mistakes with events that you can do that will be possible to fit into this talk. Otherwise, I would have to just keep pressing next, next, next on each and every slide, and I would not be talking. So it's just some patterns of behavior I've seen enough that I decided people should talk about it, so that other people can later do not repeat the same mistakes over and over and again. And also because that's kind to the other engineers that you work with, or maybe to just yourself. So if you can give somebody material, hey, watch it, and then let's talk about how we design the system so that we can avoid some things. It's about patterns of behaviors. They have happened maybe in the places I worked in, maybe in the places I didn't work in, but I talked with somebody. I will not tell you. And don't assume that it happened in a place that's mentioned on my LinkedIn, because that would be overly simplistic, and that's not exactly what happened. This has been accumulated over time. So you might know some of those mistakes. You might know that they are nonsensical to make, but that's because you know some people don't. And sadly, all of the mistakes that I've seen people repeat a couple times at least. What this talk is not is also an important aspect. I'm not going to tell you how to build a big, performant, efficient event store, event-driven system, how to start with event sourcing. Those are separate subjects. They wouldn't fit into a 1 hour slot combined with mistakes. So don't expect an A to Z or alpha to sigma or whatever. The subject is much bigger. If you want to talk about it, I'll be more than happy to. Maybe we should do something. Maybe I should write a book about it. If you believe that, tell me. If you believe I shouldn't, also tell me. And now my job is done. No, not really. So, event. The concept of event is something that we're quite used to right now in computing. So, what is usually an event? When we say event, we usually mean a discrete fact. A discrete as opposed to continuous. It's usually in past tense, so something has happened. I don't know, shopping cart has been created, order has been made, and so on and so on. Usually that means that we can attach an event to a specific point in time. So some action took place or finished taking place, and that is a very specific thing in a specific moment. This seems quite simple. And then somebody could ask, yeah, that's simple. Well, how could you possibly do something wrong about it? The answer is, well, there is mistake number 0. We're programmers. We're the programmers of the zero-indexed array languages usually. So mistake number 0 is not making events in the first place. How is that even possible? The year is 2023. We've been using events for so many years. Well, yes, but you still see symptoms like batches, operating over tables, trying to pick up what state changes happened since the last such job was run. And you can see huge audit tables, maybe even covering all entities, maybe covering all entities in different versions, maybe built on top of a CRUD in a very crude way, pun intended, or maybe very long business methods called generate bill and send updates and send email. And if you believe this method is made up, sadly, it's not. All of those symptoms say something between the lines. They say that there are events or there are actions in the system, and there are an event is an entity that's being sought. So audit tables, so looking for changes. Those changes are potential events, or something that does a lot of end. That means that there is a business process that's complex, and the next step should be triggered by the previous step completing. There is potentially a point for an event, because if there is a big process, then there is a big chance for it all failing, or the whole thing not completing, which means, do you want progression? And if you want progression, events are a great tool there. What do you do when you have such problems? Well, the answer is quite trivial. You introduce the concept of event to a system. There is a lot of startups out there. You probably have worked, or maybe you work in a company that considers itself startup or startup-ish. And if you see that, or if you think that an event is actually what we're really interested in and you're not doing that, then that is a thing that you can and probably should do. And that keeps happening. So you have an event, you come up with, maybe let's call it a business event, and then you record different actions that happen in the system, and then comes the question, what should you do? Well, we created it. If we do it in Java and we don't store it, well, garbage collector will take care of it and it will be no more. And that didn't really serve its purpose yet. So probably we want to store. Why do we want to store? Because we want to see what happens. Why? Because the events can tell a story. And that's that. That's easy. So we can store them in the same place as the entities. When I say same place, I don't mean the exactly same table. I mean, for example, same database. Or in different words, you probably don't immediately need a Kafka or a message queue or something else for events. You can put events into a database table, just append, and that will be okay, especially if you don't have a very clear-cut idea about what you want to do with them. Recording them in the first place is a very good step. So mistake 0.1, or an evolution of that, it revolves around audit tables. If you find yourself doing huge audit tables and having things like audit processors looking for changes, this means, between the lines, this thing is looking for events. This thing is trying to infer what events have happened between two different entity states. And maybe it would be easier and better and nicer for everybody if actually those changes, being explicit about what story actually has happened between those two states, and record those. There is also another aspect of not doing events and going all in on events. Doing events for absolutely every single thing in the system and then everything in between as well. Doing systems only with events and events everywhere will be very complex. Probably this is not the way. Usually the correct answer is somewhere in between. So keeping a balance. How do you figure out how you do that? Well, that's a good discussion point. But don't use events absolutely everywhere. It's not a golden hammer. It's not a silver bullet. Sometimes they fit, then use them. And if they don't, or if you think that they are overly complicating things, then don't. Some symptoms that you might discover is communicating all state changes through events and trying to combine too many things into events. Some events will be internal to the system. Some events will be external to the system. So some events will not be intended for outsiders to consume. And that's okay. That's normal. And some events that you will have in the system will actually turn out to be not very important. And you can get rid of them, and that's okay as well. And we'll come back to that later. But we have events, and events need one specific thing so we can tell them apart, and they need identifiers. So I could ask what to use as event IDs. And the year is, again, 2023, so everybody is going to say exactly the same thing, which is going to be int, long, UUID, UID, maybe nano ID. And then if we all say it at the same time, or if we all try to use all of the same types in a single system, it becomes a bit messy. First aspect, nano ID is a thing that front-end people sometimes like to use because it's shorter than UID. It is great because that's you save bytes. But at the same time, it doesn't have a syntax that you can enforce, which means for events that you have internally in the system, UUID is quite a nice fit because you can verify whether something looks like a UID or not. Ints, well, if you expose your events through an ID and you use an int, then if somebody guesses the correct int, then they can get it. If they use an int and then they use half of that max value and then do it like that, they can establish how much life you have in your system because they can see how many things are happening. If that's internal, that's okay. But the moment somebody malicious tries to do it, or maybe somebody wants to acquire your company and they want to estimate how much business you're having, maybe this isn't great. UUIDs, on the other hand, are very hard to interrogate in this way. Also, UUID has a structure, which is easy to verify, which means if somebody sends you gibberish and if it looks like a UUID, there is a good chance that it's less incorrect than a completely random gibberish of bytes. Don't mix kinds of identifiers. Usually, UUIDs are quite nice. Also, about ints or longs, I've seen an atomic long being used as a source of identifiers. It's great if you have one instance. It's great if you never restart it. If you do any of those two things, or maybe redeploy, well, good luck. Side note, nano ID, as in if you've never seen it, similar amount of bits of randomness, wider alphabet, but shorter. Web to backend, if you care about byte widths, sure, use it, but internally, if UIDs are your thing, then do UIDs. So, another aspect of UIDs is 122 bits of randomness is usually enough to serve as correlation ID. And now we can do this. UID, this is GeeCON audience. GeeCON audience, this is UID. Now you know each other. And UID is a nice thing that some databases, like Postgres, can actually store and have a dedicated type for. And then also some databases don't. Some people call them GUIs. Why do I mention that? Because there is some less known knowledge about UIDs. They have variants and versions. You probably know, some of you will know this. They might relate to the MAC address of a network device that you're generating them on. If your machine has multiple network interfaces, maybe has virtual network interfaces, you can see a problem, which is the question. And that also reduces the randomness. Some of them can be time-related, which means less randomness. And some of them can be totally purely random. Also, because the timestamp is not at the very beginning, they make poor ID if you want to sort by this, because you have to read the whole thing. You cannot just operate on the first bits if you use those versions, but we'll come back to that. So UID, yeah, timestamp. Timestamp, sadly, is measured in 100 nanosecond increments since 15th of October, 1582. I don't remember that, I read it. The other variants that you might look at, as in if you want string-related UIDs, you can see that if you use the same string, they become very similar because that's one of the hashes of that string. So they can be repeatable or they cannot. You can also use a network interface. If you can see it, congratulations. If not, I've tried to be kind to you here, so you can see what matches. And as you can see, there is more in network interfaces there. So if you change something, maybe you change your network card, your UIDs will be generated differently. And if you want to do it in Java, easy. If you want to extract time from UID, it is possible. Sadly, this method is not in the JDK as of yet, but you can write it yourself, or you can ask ChatGPT to write it. It's not that complex. This is, I would say, quite powerful. If you, for example, want to benefit from the timestamp being encoded in the UID and optimize time-based partition search or charge replica, choices, that's cool, but also misses a few things, like ordering, because if the timestamp is not at the very beginning of the UID, you have to read the whole thing, and that's less efficient than it could be. So there are more variants incoming. They are currently a draft. Version 6, version 7, and version 8. Version 8 is do whatever. Version 7 is timestamps in milliseconds, since Unix epoch. Finally, this took people a while. So the question that you might want to ask is, should I use UID as keys? My answer will be yes, but if you have events and you only use UID as a key, then how can you tell what kind of an event you're looking at? The answer to that is composite keys. So payment processed UID or something like that. Or maybe even better, composite key with the domain. Because order created or something similar will be kind of an event name that different domains will worry about, but the purchase domain will treat it differently than maybe logistic domain or shipping domain or something else. They are also very good as correlation IDs. Once you've generated this identifier, this is something that can identify a transaction flow or something in the system because it's unique enough. So, mistake number 2. Enough with identifiers, delivery mechanism. The mistake number 2 is designing for delivery mechanism. If you have a very specific design that is driven by the technology choice first and then what the product wants to do second, you will end up with nice things on the CV, yes, but you will end in problems. Common symptoms that you might have seen among some people that you know. I won't point any fingers. For example, we need to use Kafka. We need to do microservices. We need to have blockchain as a system. A couple of years ago, this was a perfect way of getting $100 million of funding if you were a startup, but not anymore. Obviously, other ways of saying that, this technology is not modern. You should use something else. Something isn't cool, something never crashes. You know computers aren't that miraculous. Use something that's simple and work. If you remember this comic, the one that says something about one data store and the other data store, and joins at web scale, you can laugh if you don't. I find it funny. Look it up on YouTube after the talk. But delivery mechanism and events. Start with the use case. If your events need to live somewhere and you don't have a solution, you can actually put them in the same data store that you put your business entities in, and that will be usually okay. DBs are surprisingly good at keeping events. I know some people might find it shocking, but at a company I worked for, almost 3 years, Postgres was used as the event distribution and delivery mechanism for events rather than, for example, Kafka, and that actually worked quite nicely. Postgres can do that. Of course, it needed a bit of software, but if your system doesn't need to handle tens of millions of users, a database will be fine. If your system needs to handle tens of millions of users, Postgres can be fine, other data stores potentially as well, or maybe you have a queue that you're already very familiar with, and that's also good. Cloud-delivered, all-in-the-box solutions, like Amazon provided Kafka, the managed Kafka, that works quite well as well. Not having to deal with an extra thing is very convenient. And so, immutability. Caveat with events and immutability. There is a conception that events will never have to mutate. It's very convenient and it's very nice and it's very correct in many at many points in time, but there is also a lot of depends, and the depends are driven by probably the industry that your company operates in, by regulations in that space. So basically, generally, the problem space. The symptom of thinking or assuming immutability or a problem that's going to head your way silently is we will never need to alter events. And if you think that your system will never ever need to handle events and alter events as well, talk to the lawyers that you have in your company and think about what is the craziest court order that you will have to deal with. If they tell you to eradicate some data from a system and prove that you have done it under the penalty of many amount of currency of your choice, and they will actually send 3 auditing companies at you to verify that you have. Then you have to do it. There is no other way around, which means believing in totally immutable systems comes with caveats. Sometimes it's not possible for certain areas. What you can do instead? Well, you will need to mutate it, basically, or close the business. So reality check. Reality check will say that you have to sometimes rewrite events or conveniently modify them. This is not going to be a default situation. This is going to be an exceptionally rare case and an exceptional case at the same time. But sometimes it happens. It depends. It is lawyer related. If your domain doesn't, if it looks unlikely in your domain, you're happy. But there are situations in which those things happen. So keeping events in a database or keeping the archived events in a database rather than an immutable queue or maybe on a blockchain is actually quite convenient, because otherwise the cost of having to deal with such a request becomes ginormous. So talk to your lawyers, talk to your business people, see if that's a thing that you can assume. Another aspect is GDPR. And GDPR, so PII, personally identifiable information floating on events. What should you do? Use identifiers, use tokens. Don't assume you can and don't assume you cannot. Talk to lawyers. Depending on domain, depending on geography, some things hold, some things don't. And also, those things keep changing. Usually, keeping PII out of events is nice and convenient, but sometimes if they refer to, I don't know, maybe an invoice, maybe an order, maybe a delivery, they actually are part of the business information that maybe you have to or maybe you are allowed to store for multiple years. Again, problem space that you have to explore with your business people. Storage is another aspect. If you want to have a lot of events and you want to store all of them, data will keep accumulating. And data will also keep evolving, and we'll touch that in a second. At first, storage is very easy to get by. It seems cheap, and it is cheap, and then it grows. Consider how long do you need to store your events for? Do you need to store all of the events, or maybe there is a natural cutoff after you can eliminate some of the events because they are no longer necessary? It varies, and set those expectations somewhere, write them down, and you will come back to this. You might have to adjust it, and that's cool, but assume that some events will eventually maybe disappear from a system. Maybe not now, but after 8 years, maybe after 10 years, because if you have a lot of old data, you have to, do you want to be able to use it? Then comes maintenance costs as well. Also, there is a caveat of having multiple delivery brokers. What do I mean? Good question. Symptoms that you might see. Multiple channels of communication between 2 applications. So there is an application A, there's application B, and it has a WebSocket, it has a JSON interface over REST, so at the same time, and maybe another WebSocket. And some people try to use all 3 methods of communication and then try to come up with a consistent state at the other side. As you can imagine, this becomes very difficult very quickly, especially if they try to use one of those as a fallback to the other, because ordering is a problem, missing events or things coming in a nonsensical way becomes a thing, and compensating logic becomes a nightmare to evolve and a nightmare to develop. The solution is quite simple. If your applications does it, try not to have simple ways of communications and don't multiply them, because that will be very, 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 very hard to get out of and make correct. Another mistake is storing events using Java serialization. And you could say nobody does it anymore, and I would so much love to agree with you, but sadly. So for people who don't know this, this serializing event on the left and then trying to read after you've edited the code and you've compiled it will break. I assume you know this. Most likely you do. If not, now you do. Passing jars around everywhere you control is awesome. But the moment you try to introduce other languages to your system, this will become difficult. So what do? Well, we have usually 2 answers that we go back to. We use JSON, and that's cool. JSON is better in a way that's not so tightly coupled to your source. But if I just put a JSON creator, use Jackson or any other JSON implementation. Is my job really done? I'm talking about this, so obviously there must be something, as in somebody could say, yeah, but is the output of the framework stable? That's a thing that you can test. What happens when I evolve my entities and I want to read the old ones? Well, that's a thing that you will need to write if you care about those old events, and then that's something that you will have to test. If you refactor a field, should it affect the JSON output? There are two ways of handling this, yes or no. If you care about this, if this is an external or internal interface, the answer will differ. My suggestion, at least write tests so that you get signals about some trivial things like that changing. And yes, I do sometimes write tests for my JSON serialization because I want this safety net. It's just better after some time. What else could go wrong with JSON? Well, different people will use different libraries, and they might approach certain aspects of serialization in a slightly different way. And then you learn about those differences the moment you try to merge the two code bases or maybe use events supplied by the other side. And that gets funny. So test serialization, test symmetry is what I just serialized, the same as what I deserialized. Test deserialization of older events. As you evolve, handling versioning will become difficult. And since I mentioned versioning events, it's a caveat on its own. And it's a caveat of its own that could be a talk, because there is a lot of depends here. And it's a caveat big enough that there is a book about versioning in an event source system. It's a nice book, you can read it. I'm not going to tell you how to do versioning well, because again, that's a talk on its own, or we can discuss it after. But if you're thinking about versioning and events and publishing this state, then you will want a schema, because your events are your interface. The problem of lack of schema, well, the symptom is quite evident. If you want to know what's in there, you have a lot of if-else when reading events. Content of the events is unpredictable, and you're trying to deal with that complexity, and it's actually being more and more and more and more painful. The trial and error will accumulate over time, which means code will be difficult. The answer, yeah, I can see it from your faces. Yeah, have a schema, obviously. Document them like endpoints. And the question that you want to ask me, the answer to that comes very quickly. How can you document your schema? Solution number A is code. I have not yet seen a company that would do everything in one language and one language alone. So doing your event documentation in Java is a possibility, but sooner or later, or most likely, you will have some Python people, maybe Go people, maybe Rust people, maybe whatever the language of the week is, and they will want to consume or talk to your events, or maybe you'll have external integration partners, and then Java becomes maybe not a nuisance, but not the most convenient thing out there. Also, you have to go analyze Java through something that's tooled to deal with Java. So code is convenient to people that develop software in a given language. If you're Java developers, it's an awesome tool. But if you want to talk to a front-end engineer, if you show them Java, they will make sometimes funny faces. The same kind of faces you do when you are being shown JavaScript. So it's fair. Fellow engineers of other technologies want their fellow things. Normal. So some other ideas. Use something that's not Java specific. Protobuf, that's a great thing. It has a lot of support out there. It's also quite popular. It's also binary, so it's going to be more space efficient than JSON. There is Avro schema, there is Avro, there is JSON schema, and then there are others. Protobuf is quite nice if you want to do binary. If you want to do JSON, I've used JSON schema, it works. And then you have to enforce it. And then you can use any tool that deals with JSON schema to validate whether what you want is what you get, so that you can pick things changing. And when we say things changing, schema and naming is a source of changes as well. Order placed. Well, what is order placed? Obvious, order has been placed, but this is going to mean different things depending on who says something or speaks about order placed. Returns, logistics, payments, it really varies. One option that you have is return orders placed, But then if you have that kind of attitude, you're going to have very long event names, and there is going to be a lot of them. Not the most convenient way out of this. What you can do is within a domain have events. So composite keys. We touched on we touched on it slightly earlier. But then somebody will still tell me that, hey, JSON is still going to be too verbose, because I did mention JSON schema, and I will say you are correct. There have been, or there are, two things that I could find on the internet that looked reasonable. I'm saying have found and reasonable because I have not deployed them to production, any of them. Sadly, async API is something that looks nice. Cloud Events is something that also looked nice, but async API is a bit more alive. Async API is Open API extended to allow for asynchronous actions. If you know Open API, or Swagger, if you didn't register the name change, then async API is the same spirit but more richer. This is what the internet and the activity in the repository suggests to go on, and what does it look like? And that's a very good question. So I have an event here expressed as YAML, because we all love YAML. We especially love YAML when we make off by one space errors. So you don't have to use YAML. You can also use JSON for it. And from the source on the left, you generate the thing on the right. The thing on the right can be put on a website. The thing on the right can be put on an automated development server through your Jenkins job. Nice and easy, also discoverable. Also, there is a place for some documentation, so you can talk with your business people, you can talk with your testers, you can talk with whoever else you want, because the thing on the right, more consumable to humans, usually, than the thing on the left. I think that's something that's quite convenient. Also, it can do examples. So that's why this screenshot is shifted to the left. So event contents, we know how to do schema. You know what I'm suggesting that you can try. How should we design? What should be the contents of the events? Should you do deltas? Should you do fact events? Which one should you do? Is this a good event? The answer, sadly, or of course, is it depends. It depends on the consumer and on the how nice you want to be to the people who are using that and what's useful to them. So if you're event sourcing within your own system, doing deltas is absolutely okay, because your system already owns the aggregation. You know about everything else that you need to know about. You're happy. Nobody cares. If you're doing events through some sort of a boundary, maybe an external API, or maybe you're consuming events from an external API, the more state that you carry with the event, the easier it is for the consuming entity or the integrating entity, the more easy it is for them to do whatever they need to do based on this event, because they don't have to do calls to fetch missing facts, which means it's nice. In human terms, you're just being nice to your users. Or you can go all the way and you can do state carrier, so all the state, all the related state, and the delta, saying what happened, why do we trigger this event, so that, again, the users of what you're doing can make informed decisions based on this. Internal state can be built out of deltas, yes, and you can fetch the state in the event from a system, from an API, sure. When would I not do that? If this means that if the entity that I'm sending events about doesn't change too much, so the deltas are very small and the state is big, or I can be quite sure that the other side has complete or very at least comfortable level of knowledge about the entity that's being emitted as an event. So there is more, happy to discuss more afterwards, but think about it. The bottom line is it's not a uniform answer across all the systems and all of the events and all of the endpoints. Make something that actually makes sense. And we can have a look at another mistake, guarantees. I see people smiling, that's awesome. The answer, or the question between the lines is, can you tolerate missing events? There are two extremes. One says you want at least once delivery, another one is at most once delivery. What should you check? You should look at something called inbox-outbox pattern if you want to be sure that you're emitting events within a transaction. And you should also use idempotency keys if you want to guarantee or help guarantee that you're not reprocessing the same thing over and over and over again. Be careful when Googling, because that's what Google told me. It must be true. Who here uses inbox or outbox patterns in their applications? I see roughly a third of the room raising their hands. So an outbox pattern or an inbox pattern is, let's start with outbox. Outbox is a pattern in which, as you do a transaction, within the same transaction, think even the database transaction, you also store the events that you want emitted. And then there is something, the event delivery box, that will read those events and put them onto the event publishing thing, on the broker, queue, whatever that is. That means that you are atomically making the transaction, changing the business entities, and storing events. And that improves their chances of being delivered, but at least you're guaranteed to have recorded them if you've done the business logic that you care about. What could possibly go wrong here? What could go wrong here is the event table will be read very often from, or a lot if you have a lot of events there, and it will also be written to, which means it can grow, and you probably want to delete from it eventually because it can outgrow your database's disks. And also that means if you use something like Postgres, vacuum will be a thing, which means that's a very good point to put monitoring on and have warning signs. If you are comfortable with, let's say, under 10,000 events in there, everything is merry. If you have more than 1,000 or 10,000 or the oldest event that you have in the event table that still needs to be delivered is older than an hour, then you probably have a problem in the system. Don't ask me how I know about this, but you can infer. So another mistake that people do with regards to data and delivering of events is massive events. Massive events like, I don't know, somebody tries to send a megabyte, or somebody tries to send a couple megabytes, maybe 100 megabytes. In most cases, this is a big problem. Why? Because you have to transport over the network, you have to store it, you record it in every single place, you maybe even log every single event that you receive. Why would you do that? But some people do that. If the body is big, that takes a lot of space. Too much information is serialized, stored, transmitted, You get the idea. What to do if that happens, or how not to get there? Set limits. Set maybe very aggressive limits, or maybe not very aggressive, but reasonable. Is 128K big for an event, or too small, or maybe just right? I don't know, because it depends on your domain and what makes sense. If you're dealing with images, this will differ in answer to when you're, for example, dealing with bank transactions. Set something appropriate, and when you cross it, consider raising for maybe one kind of event only, but at least have a signal so that somebody's doing something potentially nasty or something that's potentially exploding, because this will help you when performance problems arise. And then comes the time. Time should be simple. Event, discrete fact, we know when it happened, and then you put a timestamp field on the event, and then you read the timestamp, and what does the timestamp mean exactly? There can be different interpretations. When something happened, when system received something, when system emitted an event, it can be anything else as well. When is a very tough question. One answer to this is use Lamport timestamps or processing counters in human terms. So something that's an incremental thing that as you process an event through systems, you keep bumping it up. So you can see how much journey the thing has. But also the more practical or the immediately applicable thing is be very specific about what you record, and record the things that matter and record multiple of them. Create that, receive that, process that. If you need all of those viewpoints, record them. It's not going to be a terrible waste of space in most cases, but this will help you when you have to debug something. And sadly, this eventually happens. Be very clear about what time zone you're specifying there. Is it Pacific time? Is it Pacific time with daylight savings time? Is it Zulu? Is Is it London? Is it London summer? People do different things. People have different conventions. Sometimes people just use the system defaults. If you need a default, UTC is awesome. But UTC alone is difficult when you have distributed systems because clocks, because time drifts across different machines differently. At least use NTP in your system. If you're running Kubernetes, you can get events that you will receive and they look like they came from the future. This happens all the time. That's normal. There are ways to enforce time synchronization on pods, or if you're trying your systems in Minikube, you will run into this kind of problem. Think about time synchronization. This will help a lot because at least you will have monotonic time, and that's a very convenient guarantee to have about your system. Another problem, or another mistake, denying distribution, or pretending everything is atomic across the whole system. Well, we know that it's not. Transactions die, databases die, VMs in the cloud die, regions in the cloud die. Hopefully, no whole clouds die yet, but I will never say never. And the worst thing that could happen is that you don't know about it. So there is a silent failure, and you have a bunch of transactions that died sometime in processing and you don't even know about it. Why can this be very hard? Because events are published and consumed independently. Nobody really looks at the whole state of a business flow. There are silent dependencies. There is silent coupling that can go off rails and then can go in a strange direction very, very easily. Some entities will reach states that make no sense. Those can be called impossible states. And what are your solutions? Well, first, the question is, from a business process point of view, how do we understand the concept of now? When you ask the question at the end, at the specific moment, can we be more specific? And then when we have that defined, so the time at which we are asking the question, can we look at eventual consistency? And if you are doing eventual consistency, so the assumption that systems are immediately inconsistent and eventually they reach a nice state, can we have some sort of an automated thing that looks at our processes and picks the ones that are stale? Something has to notice that something didn't really happen. If it's a customer, awesome, but not awesome. Because, well, somebody told us that something is wrong, but something died and we didn't know about it, and the customer has to reach out to us. If we have 1 million customers, it's going to be a pain for the customer service team. If you're doing machine-to-machine communication and nobody's going to call you because, well, those are machines that just things die, this is going to be quite bad. So think about, if everything is event-driven, how do you monitor the whole business process? And then between the lines, what I'm saying here is event-driven architecture is very nice, but don't apply it absolutely everywhere because it comes with complexity. Complexity, so tracing, because we want to debug something. So symptoms, we cannot say where did the event come from, where are we heading, where are we in, what is the journey of a specific thing. If you like microservices and events, there is a very nice picture that to me is scary, to some people is very nice if they are graphically inclined. Software engineers usually also find it scary. Those can be microservices. The really good thing here is you have connections which are evident because they are connected. Now imagine you are doing events which are asynchronous. You put something onto a queue and you don't know who's reading from that queue, who actually depends on things. And then, or differently, endpoints are very explicit. Depending on events, which is nice because it decouples things, is also making things difficult because you have decoupled things. Circular flows become very easy to get. You can have that, and that's why I mentioned processing counters, because if you have an event that reached a processing count of maybe 1 million, something has gone terribly wrong. Obviously, when it reaches 1048,576, we celebrate 2 to the power of 20, we give it a cake, and then wait further. But hey, this shouldn't normally happen in a system, probably. Asynchronicity hides complexity and does it extremely well, which means it might bite you. Or if you don't pay attention, it will bite you and you will not know about it because it's going to be an asynchronous bite. So what should you do? You should trace. Easy. You should use a tracing ID so that you can say, why do we do this? What is the origin, maybe the event, the idea of an event that kickstarted the whole application or the process that we are analyzing. And this is where UUIDs that the ones we mentioned early on, domain plus name of event plus an identifier, comes in because we can then correlate things happening across different systems. Pass this same ID from one system to the other, and then have checks, which should hopefully keep being green, about circular dependencies. If you notice any, fight them and fight them aggressively. If you're building a new system, it's much easier. But if you're dealing with an older system where maybe some circular flows exist, well, this will be hard. And yeah, this will be hard because it is hard. But I just wanted to highlight that. Now, another mistake, not thinking which events matter. So I already hinted at this. Not all events carry the same weight, are as important as the others. So how do you pick? How do you make those decisions? How do you make the distinction? Is it an important event or is it just a technical thing that we don't care about? Two software-driven ways, hard to roll back moments. After you ship an order, that sounds like it gets harder to modify reality to match the computing system. Anything like that is a good candidate. And stuff that people care about. How do you pick those? How do you identify those? If your system is modernly architected, then you probably know. But if it's not, or if you're dealing with a domain that you don't know much about, and you have to discover those events, there is a technique called event storming. I'm not even going to try to tell you what event storming is. I'm just going to highlight the term. Who here, out of curiosity, has tried event storming? At least once. I see just a couple hands in the air. Read about it. Try to do that when you have to deal with a new system, a major system change next time. If it helps you, you win. If it doesn't help you, don't get discouraged. Keep trying, because this will help, and this is, I find it a very useful technique. It's very powerful, but it also takes some time to get right. There is a good talk from everybody's favorite software journalist about not all events being equal. I'm not going to say what he says because the video is out there, so if you want the links, click on them. But that's that. And then we get into another problem, poor quality systems. Dealing with poor quality systems, maybe integrating with poor quality systems, which means we get events which are of questionable quality. Maybe there is a place on Earth which just generates terrible events. Maybe. Maybe things are hard to debug because those systems send us doesn't match what we query through an REST endpoint. That can happen. Maybe there can be a lot of maybes. Poor quality, I think, is easy enough. So what should you do? How can you deal with that within your own system? As in, within your own system, that's where you have control. So within the system that you own, I would suggest try to apply DDD's ubiquitous language. So within one domain, be specific about what you mean and model it nicely. Sadly, the outside world will keep being messy because the outside world usually is messy. But you can use something called anti-corruption layer, and then within the system, only have nice things. So why can't we have nice things? Well, within our system we can, but it requires some work. And I'm going to start skipping some slides because I'm going to run out of time very soon. But I wanted to mention this. There is a kind of people who learn about CQRS, or maybe design patterns, or maybe event sourcing, or anything else, a technical solution to a problem. And it looks very cool, and it is cool. But some of those people need to be put under a glass dome for half a year so that they can cool down before they can be allowed to code in production. Why? Because they want to apply every single thing that they learned everywhere. Does it apply? That's not a question they are going to ask. It's we need to do more, and more patterns, more everything. Sometimes a CRUD, an API to the database, literally, is a correct solution to your problem. Sometimes CQRS, or sometimes using CQRS in the parts of the system only, is the correct approach, and using CRUD elsewhere is okay. Sometimes mixing CQRS and event sourcing is correct, but it's most likely not across the whole system from the get-go. How do you make those decisions? Well, that's another conversation. Maybe there should be a book in the Java world about it. But I should also recommend some other books, because if this subject you find interesting, then what is the recommended reading? Well, I find these books relevant, especially the top right one. I know it's in Python, so spaces are significant, but the book is actually quite good if you've not done a lot of domain-driven design and you want to see some patterns being introduced on something quite simple. The blue book is the classic, but it's hard to read. That's my opinion. I find it hard to read. It's awesome if you can spend half a year studying it, but it will take time. If you need a starter, pick the top right. If you also want to learn domain-driven design, the left one is also quite good, and then the bottom is absolutely awesome. And I have to mention that there is a controversy. Is the data in the book actually reliable? It turns out probably not, because it has been falsified. I still find the book quite relevant and inspiring for distributed system developers, even though what it's built on is quite fake. So I should say thank you. And if you want the slides, email. How do you email? Easy. Or tweet or anything. And I should check Slido. How are we on Slido? Do we have anything? We have questions. So I'm going to be a terrible person. I'm not going to share my browser. If you have it, can you show it to me? That would be probably the easiest. So what is wrong with audit table? If you have to track change over the time, is there a better way? It's not that audit tables are bad in themselves, but if what you want is, if it's how you use the audit tables. If you want to infer, if you need to infer what happened between different entries in the audit table, then what you're looking for are state changes. I'm suggesting that sometimes what you want to store is the state changes and not the raw data. So there is no generally wrong or generally right here. How would you solve the problem of having to add new field to an existing event? New type of event, or use the existing event and rewrite the whole topic? I would usually, or it depends. If I can get the data point that's being added, and it will help me, and it absolutely makes sense to rewrite, then yeah, I consider rewriting. But there will be data points that you simply haven't captured, that version -1 doesn't know about, because it didn't exist in the system. Because you've built an integration, maybe you've built something, maybe you now capture a data point that you couldn't before. That will keep happening in your systems. And then previous concepts of those events, previous incarnations, will no longer have them. And that's okay, because that reflects what's happening in the domain usually. On the other hand, if a missing field can be easily recreated, and it's essential and extremely convenient to have it, I could consider it, but I would probably I would think about before doing that. If you want to talk about a specific problem here, let's grab the corridor after this. How do you approach what to put in the event? If you know that the system processing the event is going to use some fields, so you want to avoid additional API calls. If that's within the company, you can see what calls do they usually make when they need to process, or you can, if you're building a library or an API that people are going to consume in a way, try to put yourself in the consumer shoes and see if they need to do it, what is the correct way of handling that? Do they really need to get the static customer data every single time? Maybe you should ship it. Then details depends, and details will depend. So if the author of this question has a specific scenario in mind to discuss, let's handle this after. And I am afraid I've run out of questions, so the only thing I can say is thank you very much.